As competition in generative artificial intelligence, AI, becomes more intense, companies are spending huge amounts of money to secure semiconductors for data centers. That is because faster AI requires the latest semiconductors and servers. Accordingly, instead of endlessly producing fresh hardware, moves are surfacing to make use of the processing power found in devices already built. As this approach recycles a device's own capabilities, it is emerging as a novel type of digital recycling. Urban mining. The process of recovering metals from discarded electronic products is commonly called urban mining. The circuit boards of smartphones and computers contain various metals, such as gold, silver, and copper. In urban mining, collected electronic products are dismantled and crushed, and then the metals are extracted by melting them at high temperatures or using chemical solutions. Urban mining, however, is unable to retain a product's functions. Even when a semiconductor remains functional, its processing capability is lost as soon as the circuit board gets crushed. Recovering the metals and using them to manufacture new semiconductors likewise requires substantial energy and money. In addition, the costs and risks of processing electronic waste are not shared equally around the world. Some electronic products discarded in developed countries are transported to developing countries. In places without proper facilities or protective equipment, workers can be exposed to toxic gases and heavy metals. That is why urban mining is not always the best first option. What makes more sense is reusing their functions first, so they last longer, before safely reclaiming their metals at specialist plants only once they've truly stopped being useful. A supplementary solution in the age of chipflation. Chipflation is one factor behind the growing interest in digital recycling. The term fuses chip and inflation to capture how prices for chips and related products are rising alongside surging semiconductor demand. Only a small handful of companies, notably, can manufacture advanced AI semiconductors, and expanding their production facilities demands enormous amounts of time and money. However, discarded smartphones cannot simply replace the latest AI semiconductors. Training large AI models requires very high-performance semiconductors and communication networks, which smartphone chips cannot handle. On the other hand, lighter tasks, such as educational programs or simple data analysis, can be processed by systems that connect multiple smartphones. By dividing tasks according to what existing devices can handle, high-performance semiconductors can focus on tasks that truly require them. Digital recycling is a proposal to view discarded devices not simply as sources of raw materials, but as computers that may still have useful work to do.